This tutorial will be about overcurrent relay testing using the Raptor. The Raptor system, as you possibly know, is a test device specially designed for primary injection. But anyhow, it has some special resources that allow to make some direct testing on protective relays using secondary output. This tutorial will be divided into brief exercises. What you can see is the relay that we are going to test here. Okay, the Raptor system, the high current output from the Raptor, and a current transformer here. So the current transformer will be used to downsize the test current. Okay, using this output in the Raptor, we will be using thousands of ampere. So in order to test the relay, we need to downsize the current using this transformer. Okay, downstep the current to secondary values. So we are taking the secondary winding output to the relay. Okay, primary output, current transformer, secondary output, relay. Approximately, this is the connections diagram corresponding the setup that we have here. What you see here, okay, this is the Raptor system, the high current cable going across the primary of the CT of the current transformer and the secondary outputs of the transformer connected to the relay. This is what we are going to use, just a Raptor master unit, okay, this unit here with the commander that you can also see on the top of the table. I will show you now. And this is the type of cable that we are using in this setup. Okay, so if you take a closer glance to the Raptor elements, you will see the main current output, which is used for primary testing. Okay, this is the characteristic hole in this product. Okay, you just insert the high current cable here and take both ends to the receiver of the test. It can be a circuit breaker, a transformer, whatever. Okay, so and also in parallel to this, we have an auxiliary output, which is a conversion of the same power. Okay, the output power of the master unit, the master Raptor unit, is 3 kilovolt ampere. So the same power you can get from this smaller connections here on the right side of the unit. I will show you on the camera. Okay, I think you can see it now. Okay, so this is the auxiliary output. It can be used alternatively to the primary current output. Okay, this is designed for smaller currents but higher voltages. Okay, there are a lot of applications that you can use this auxiliary output for. So we are flowing high current across the primary winding of the circuit breaker, taking the secondary output to the relay. Okay, this small camera will show you here on the screen. It will show you in the top left right corner. This one here will show you a small indicator when the relay picks up. I mean, when the relay is measuring fault current. Okay, so you can have some feedback of the relay response to the different values of current that we are going to inject. And at the bottom right of the screen is a replication of the Raptor commander. Okay, exactly this commander is being replicated because I have connected it through the local area network, okay, to my computer, so I can replicate the control screen on my computer, and I can also partially control the Raptor from my computer. For example, if I go to the menu, okay, I go to the menu, I can navigate through the different option sections on the Raptor. I can select a test template. There are a lot of test templates. So we have the general test template. This is used for general purpose. This is a completely customizable template. You can modify any parameters in this template. Templates make it easy for you a particular type of test. Okay, so we have created a collection of templates for you. Okay, so you can use them directly off the shelf, or you can even customize them and save in memory modified version of any of these templates. All right. So in this particular example, that we are going to use the overcurrent relay template. So I load it. And this is what I get. The first thing I need to do is to convert the timer reading, which is here, to a chronometer. As you can see, it is now in countdown mode. So it will start counting down from 8 seconds in this case, and will stop the test after 8 seconds have elapsed. And this is not the way I want to use the Raptor now. I need to just start the injection and measure the resulting trip time. Okay, so I will double click on it and modify the timer mode to chronometer. All right, so I validate it, and now we have this as a chronometer. Okay, another important things to know is that you have to declare, you have to inform the Raptor how many turns you are doing with the cable. The cable is this, okay, and in this case we are doing just one turn. Okay, we are just inserting and coming from the other side and directly to the load. But we could make multiple turns inside the unit to multiply the injection voltage in case the impedance is very high, if you are using very long cables or whatever. Okay, this will increase, this will multiply the output voltage, so it will allow you to test larger impedances. And also in this particular case we are using 2 cables in parallel, as you see. Okay, this is not just one conductor, there are 2 conductors in parallel doing just one turn inside the Raptor and going to the load. We do this because we are working with currents in the thousands, and this particular cable is okay for 400 ampere. Okay, but if you submit it to more than 500 ampere or so, it will become very hot. Okay, it can be damaged. The insulation and the shielding can be damaged. Okay, so we are using 2 cables, and it will also make easier to achieve a specific amount of current. Okay, the larger the number of cables you use, the more efficient will be the power output from the Raptor. All right, so I am declaring in the commander that I am only doing one turn, even though we are using 2 conductors. It's just one turn. Okay, I validate it. Okay, and what I'm going to do now is to inject just a small amount of current, for example 100 ampere. Okay, I adjust 100 ampere here, enable the output, and activate. You see, I need to activate in the unit, and now the Raptor has evaluated the load, and now it is able to inject exactly the required, the selected amount of current for the test. And this is a rough representation of the characteristic curve that we are going to test in this relay. Okay, the different test points are expressed in primary current. Okay, this current transformer is 500 to 1, so it's multiplying. 1000 ampere will inject 2 ampere in the secondary. Okay, and as the relay has a setting of 2 ampere, you can see it also in these graphics. 2 ampere represented here. This is the nominal current setting on this particular relay. Okay, so any value of current equal or smaller than 2 amps will produce no trip. So this will be the points that we will be testing against this relay. Okay, to follow the characteristic curve. Can you see the save button here? This button is grayed out because I have not yet opened a report. The report is the collector of the test results. So I need to go to the menu, navigate to reports, and create a new report. In this case, this is a completely new system, so the commander is completely empty. I will name this report like relay testing tutorial. (22nd January). Okay. Description, 2 examples. So I close this this window, close the menu. Okay, so what I have done so far is to set the timer to time measuring mode. Okay, there is one thing that I also want to do is to add an ammeter to this screen. Why should I want to add an ammeter? Okay, the Raptor has an ammeter, and I'm going to use it to display here the secondary current that is being actually injected on the relay. So if you look at here, you can see a yellow conductor. Okay, this yellow conductor is taking one of the legs of the secondary injection across the ammeter in the Raptor, which is here. Okay, this is the Raptor ammeter. Okay, and the bit binary input is here. Okay, so the relay is connected to the binary input here from the relay contact, and the current input in the relay is coming through this ammeter here. So what I want to do is to represent the readings of this ammeter in this template, in the overcurrent template. So to do so, I go to options, go to the meter section, and select the ammeter as a part of my template. So now you see we have an additional meter here, and this is measuring the current across the secondary output of the CT. Okay, so any injection that I do will show the secondary value, the conversion made by the CT in this small display here. And here you will see the time for tripping. Okay, and here of course you will see the amount of current that I will select for each test point. So first test point, we are going to do a calibration again because the Raptor has timed out. You see this orange indicator here. It means that it needs to recalibrate the load again. Okay, so I just enable the output with this small amount of current and start. You see, in this small injection, this short injection, the chronometer has not started. So I cannot take it as a test. It has only been used for calibrating the Raptor output. It is very important for very short tests, because in short tests you need that the output current is exactly the amount of current that you are demanding here from the very beginning. Okay, you cannot afford to allow the unit to self-calibrate during the few milliseconds that starts the test. Okay, because this could produce erroneous time trip times. Okay, so now the Raptor is ready to inject any current value that I select here from the very beginning of the test. So if we go to the diagram, I think that the first test that we had, yeah, it is 1000 ampere, which means 2 amperes for the relay, which is the setting. In this adjustment, if I inject 1000 ampere, the relay should not trip. So let's go back here. Okay. We adjust 0 here. Okay, this is 1 kiloampere. Okay, so I enable the output and start. You can see that when the Raptor is injecting, it's outputting. There's a red light here, and also in the commander, you can also see a red light that you can see replicated on the screen. Okay, so it's now injecting 1000 ampere to the primary side of the CT. In the secondary, what we have is 2 ampere, you see? Okay, because this reading is showing the secondary output of the CT that I have connected to the ammeter. All right, so I can even modify dynamically the output. Okay, now I'm going to 0, but I am going back to 1. Okay, I can select a different for a fine adjustment. You see, I think that you have seen the pickup light coming on the top right corner of the screen, and now we have a trip time. Okay, but this is not a valid trip time because I have been injecting for a very long time with a non-tripping amount of current and so on. Next value in the curve is 1250 ampere, which corresponds to 2.5 ampere in the secondary. 1250. So we select 1250 here. And start. Okay, we are now in a trip zone. So we save. We click on save. When you click on save, you can just save the results, okay, in the report, or you can even overwrite a previously made test, or you can even add a description. Okay, we are just saving the test so you can see what is saved if I don't specify anything else. So now it's saved, and let's go for the next value in the curve. Next value in the curve is 3 ampere in secondary, which corresponds to 1500 ampere. Okay, 1500. So we select 1500. And start. So this is the trip time corresponding to this amount of current. So to 2.2. Okay. Next one is 2000 ampere, which corresponds to 4 ampere in secondary. So let's go back here. 2000 ampere. Directly increasing this. We go to 2 and just inject. And this is the tripping time, 1.5, almost 1.6. We save it. Continue with the curve. For the last point, 2.25, which corresponds to 4.5 ampere in secondary. 2.25. 0.25. Okay, this is the new trip time, 1.4. So we save it. Okay, and that's it. We have finished the test of this relay. We will give a look to the results report, okay, later. So we go to the next example, which is using a different setup. Using directly secondary values without using any CT. Okay, the Raptor can be used also to inject directly secondary values using the auxiliary output here. Okay, you see, it will be injecting directly secondary current values to the relay, and we will be detecting the relative exactly the same way as we have done in the previous example. Okay. In this case, the test values are represented in secondary. Okay, so I need to make some cabling changes with your permission. We have the auxiliary output to the relay, and we are going to change the test template because we are not using now the high current output. We are using secondary currents directly into the relay. So let's change this. Menu, templates, choose the general template in this case. Good, we change the output to auxiliary secondary in current mode. You see there is a voltage option, which means that I can also use the auxiliary secondary output as a voltage source, okay, for voltage testing. And now I have to select the binary input as the type of event that I want to monitor to detect relay operation. So let's go for the first value in the curve. We will adjust 2 amperes directly. 2 ampere. You see the chronometer starts again in an infinite counting because it will never detect any tripping activity on this relay under 2 ampere. Okay, so let's stop and go for the next value in the curve, which is 2.2. Go to 2.2 and start. And now we have a trip. That's right. Okay, we have 3.78 time. We save it. Go to the next value in the curve, 2.5. Start. And your trip time, just save it. Next value in the curve, 3 ampere. Start. Save the resulting time. Next value, 4 ampere. Start, and we get an almost instantaneous tripping, 0.1 at 4 ampere. I'm not sure if it's okay. Yeah, it's repeating. So we just save. And we can try with 5 ampere. Okay, that's it. Save again. And that's it, we have finished. So we can give a look. We disable the output. We can give a look to the report, the resulting report. We just select view here. So you see, you get in the report, if you don't specify any specific description and use your keyboard to enter a description and so on, what you get recorded in the report as a minimum is the name of the template that you are using, the timestamp of the test, which is the date and time, okay? The description, if you have written any, okay? The general conditions of the unit, what is the frequency and phase synchronization? In this case is the supply line. We have not chosen any options in this matter. If there is a polarizing option, the polarizing option allows you to detect polarity errors in an installation very quickly. And what is the selected output level for this particular test? Okay, so we started the test with 1.25 kiloampere, which was 2.5 ampere in secondary. So we got at this current value, we got this trip time, 3.3 seconds. Okay, we can start skipping from one test to the next just by clicking on this arrow. The next test, the following test current was 1.5 and we got 2.193. Okay, the next one was 2 kiloampere and we got this trip time and so on. Okay, and then we started with the second example. In the second example, you see the name of the template is different. It's general. Okay, in the first example, the name of the template was overcurrent. Okay, and the second example, the name was general. So we from here on in this report, we have a different collection of pairs current time. Okay, 2.2, 3.7 in the time. We go to next, 2.5, 2.6, 3 ampere, 4 ampere, 5 ampere. Okay, and this is the last one. So this is a very simple way of taking a fast glance to the results report. Okay, the correct way is to transmit these results from the commander to the computer and to create a more elaborated formatted report, and even you can export the entire report to Excel or PDF to share it with somebody else. Okay, so this is the tutorial. Thanks very much again. Goodbye to all.